Oh, hello there. Hey guys, what's going on? The memes here. I apologize. I was doing a little bit of rocking out a little bit prematurely. Why? Go. Oh, wait. Sorry. I ruined it. I ruined it. I was going for the Go Eigen Rangers. Apparently, a bunch of scientists at the University of Chicago. They've learned how to make a particular quantum domain wall. They've observed it, and apparently they can recreate it, and it has some absolutely fascinating properties. Let's go take a look at our little trail of stuff and things here. All right, as we can see here, scientists create strange quantum domain walls in laboratory. And this was brought to us by physics.org. University of Chicago scientists have been able to create a new type of quantum object at will in the laboratory, domain walls. So if we look at the doobly-doo here, don't obscure our doobly-doo. Okay, so basically these are groupings of several different types of atoms. But by basically putting in a Bose-Einstein condensate, basically they get it really close to absolute zero. They use some magnetic fields around it to adjust the molecular flow. And apparently, right now, they're using a whole bunch of lasers or something to basically get the molecules to do exactly what they want. And apparently, they got these domain boundaries. And the fascinating thing about this is when you push it right, a particle will go right. This goes left. Kind of like me looking at this thing here. And I find that fascinating. Let's continue. The discovery can help researchers better understand exact quantum particles and could suggest avenues for new technology in the future, such as quantum electronics or quantum memory. Published second in the journal Nature, research conducted in Professor Chang Chin's lab, where which studies novel quantum systems and the physics that underlie them. In one of their experiments, the University of Chicago scientists noticed an intriguing occurrence of atoms at extremely low temperatures. Under the right conditions, a group of atoms can segregate into domains and form a wall. Uh, Forms at the junction where they meet. This domain wall behave like an independent quantum object. That sounds pretty frickin' sweet. Some may say groovy. It actually kind of looks groovy. Look at it. There's some grooves there. I'm just saying. I'm just saying. But I see you there, Jen. Oh, welcome, Jen. As well as Wiz. I see you there. And okay, Jen was right again. She's like, membranes, bro. And I'm like, you get a domain of one type of atom, you get a domain of another. What the heck is that doing? It probably just really cool. Wait, if I push it this way, it goes the opposite? I'm not saying it's another realm, but it kind of sounds like another realm. Time will tell. I believe. Sometimes you just gotta have a little faith. It acts kind of like a sand dune in the desert. It's made up of sand, but the dune acts like an object that behaves differently from individual grains of sand, said PhD student Kai Zhuan Yao, the first author of the study. Scientists had a glimpse at these domain walls in quantum materials, but previously they couldn't reliably generate and analyze them. Once the University of Chicago physicists created the recipe to make and closely study the walls, they observed surprising behaviors. We have a lot of experience in controlling atoms, said Chin, who was appointed in the Department of Physics, the James Franck Institute, and the Enrique Fermi Institute. We know if you push atoms to the right, they will move to the right. But if you push the domain wall to the right, it moves left. So go right to go left. See, when I'm doing the right, it's going left here. Maybe it's observer dependent. Work for Professor Einstein. These domain walls are part of a class known as emergent phenomena, which means that they appear to follow new laws of physics as a result of many particles acting together as a collective. We're probably going to need to model this. Only we had a clue. Chin's lab studies these emergent phenomena, believing they can shed light on a set of laws called dynamical gauge theory. Gauge theory, you say? I remember Dr. Eric Weinstein was really big on gauge theory. He communicated that into my skull. It basically depends on where are you? I'm at 625 feet sea level. Where is that? I don't know. I'm at Mount Everest. I'm at 20, right around 5 miles, 28,000, 36,000, whatever. Within the same order of magnitude. Yes, it is the order of magnitude if you're using log base 10. Thanks, Jen. But all I know is I look at this, I'm like, all right, so I'm hearing a lot of the same words again. I'm a science enthusiast on the sense of stuff and things. Blah, blah, blah. All right. Which describes other emerging phenomena in materials as well as in the early universe. Going to dynamical gauge theory there. The same phenomena held together the first particles as they clumped together to form galaxies, stars, and planets. This is absolutely fascinating. It seems like it's coming at precisely the right moment. Breakthroughs in the field could also enable new quantum technology. Scientists are interested in cataloging these behaviors because they become part of the basis of future technology. For example, the basis of modern GPS stems from scientists in the 1950s trying to test Einstein's theory of relativity. Why, thank you. There may be applications for this phenomenon in terms of making programmable quantum materials or quantum information processor. Can be used to create a more robust way to store quantum information or enable new functions in material system. But before we can find that out, the first step is to understand how to control them. Well, that's part of the story of humanity. But so this was just absolutely fascinating, and pretty much everything in that article, if you just literally do domain walls and then like news on the Googles, basically, well, we just pop over. I follow the stream of articles just because it's like, all right, who's saying what? This is from space, so I'm like, all right. That's why I went to physics. So let me narrow down. It was published in Nature. All right, we get this abstract. Yeah, as elementary excitations, we find the domain walls to respond to synthetic electric field with a charge to mass ratio larger than and opposite to that of the bare atoms. I wonder if it's some form of bifurcation. Our work offers promising prospects to stimulate the dynamics and interaction of previously undecided. Where was it? Results in two different momenta. All right. I just remember in this at one point it's like uh it, it seems to say it's going the other way too. And then you basically just go to the University of Chicago News because well they're the folks that did it, and basically this is just kind of the quick overview there. I find this is absolutely amazing. And I really hope we don't destroy ourselves before we get to see this through, just because just a brief search of just the quantum stuff as well. And I realize some folks may say it's a buzzword or something like that. And it totally is. It's a good way to confuse people and make it sound fancy and expensive. It often can be. But here's where we go here. Okay, that was the last one. It's really exciting because if this is true, and I tend to believe that we at least have the potential to do these things sooner rather than later. Okay, Quantware from TechCrunch. Quantware will build you a custom 25 qubit quantum processor in 30 days. I have no idea the price, but that sounds fascinating. And again, this sounds like a claim from a new company. Now, what will that do for you? I have no idea, but researchers unveil hybrid 512-qubit quantum array with zero downtime. Zero downtime, you say? Seems like it's flowing together. Building arrays into two different qubit types can be key for quantum scaling. So 2 is kind of important. I believe Dr. Leibniz had something to say about that. Oh, look at those pretty shapes, too. Physicists steer chemical reactions by magnetic fields and quantum interference. New research provides insights into how quantum mechanics can control ultra-cold chemistry. So we'll be able to get better yields and probably some much cooler compounds and everything. Thank you, folks. Black hole event horizons are tunable factories of quantum entanglement. Okay, that's not necessarily what I thought it was, but then again, nobody would ever troll, especially physicists. Oh, it's kind of tube-like. It's Taurus. I wonder what action it's going to undertake. Oh, look, yes, measurement. Oh, yeah, and quantum batteries could become a reality with super absorption. I totally didn't look into that, but all I know is they put super in front of it, so you got my attention. It works for Saiyans and apparently like Superman. I don't know. A lot of people seem to be fans of Henry Cavill. I can't imagine why. But that's all I really got for right now. A little bit of positive news out there in this world of stuff and things. Great things are in the future. I think we all have a part to play. I see you there, Brian. Thank you all for joining. Peace out, everybody. Be safe. And no matter what happens, you got to remember, some of us are on a quest to find out.
It's turtles all the way down.
I can neither confirm nor deny.
Have you guys checked out the Memes of Destruction's channel? He's an interesting